What the heck? Testing, testing. Got it. Given the circle r equal 1 and the cardioid r equal 1 plus cosine theta, find the area of the region inside the circle and inside the cardioid. So we've done quite a bit of the graphing, so I've just pulled it up here, but you could graph it r equal 1, and then you could draw this in rectangular coordinates, then draw it out and get this cardioid right here. So we're after this shaded yellow region inside the circle and also inside the cardioid. Your best bet is to draw a sketch and have a look, because that's going to help us know what integral to integrate and how we're going to put this together. Now, as I look at this, the easiest way to do this, as I see it, is to divide this into two pieces. And this piece is a half circle, and I know how to find the area of a half circle of radius 1 very easily. And then if I find the area of this piece and I double it so that I have this lower piece like that as well, I can add that to the area of the half circle. So draw a sketch and go for the easiest thing. Look at some of the geometry and let that help you. So as I'm trying to figure out the total area, that's going to be area 1 plus area 2, and we'll have this be our area 1, and then the shaded red will be our area 2. And so we already know that area 1 is going to be, the area of a circle is pi r squared, and our r is 1, and we only want half of a circle, so that's just going to be 1/2 pi. Now, in order to find this piece, we are going to then integrate, and let's see how we would comprise that piece. It's from pi over 2 as we're coming around until we get to pi. We know that at pi this would be -1 and our r would be 0, and we'd come back in. So we are going to integrate from pi over 2 to pi, and our formula was 1/2, which we'll put out in front, and then our function of theta, which is 1 plus cosine theta squared d theta. Now let's go ahead, and so this would give us our area 2. And then if we took that and we multiplied it by 2 so we could get that other piece on there as well, this would give us area 2. So those will just cancel there. So let's see what we've got here. So area 2 is going to be the integral from pi over 2 to pi of 1, I'm multiplying this out, plus 2 cosine theta plus cosine squared theta d theta. And we know from our little trig identities that we could replace this with 1/2 times 1 plus cosine 2 theta. So this is going to be theta plus 2 sine theta, and then working here plus 1/2 theta, I went ahead and think of this distributed through, plus 1/4 sine 2 theta. And this will need to be evaluated from pi over 2 to pi. Let's go ahead then and do the evaluation. So we're going to have pi, and when we put the sine of pi in here, that's 0, so that's gone. And this would be plus 1/2 pi. And here we'd have the sine of 2 pi, which is also 0, so that's gone. And then doing our lower limit, we would have minus pi over 2. Putting pi over 2 here, the sine of pi over 2 is 1, so we have 2, but it's our lower limit, so remember we're subtracting it off. And then here, if we put in pi over 2, we'd have minus pi over 4. We got to subtract all of these. And then when we put pi over 2 in here, by the time we multiply it by 2, we get the sine of pi, which is 0, so that's out of there. So if I combine all of these, I will have my area 2. So area 2 is going to be, well, here we have pi over 2 and a minus pi over 2. So it looks like pi minus pi over 4, so that would be 3 pi over 4 minus 2. So we have area 1 and area 2, so our complete area is going to be 1/2 pi plus 3 pi fourths minus 2. So as we simplify that, this is going to be 2 pi fourths, so adding those together, 5 pi fourths minus 2 for this yellow shaded area.